Hello everyone, I am Mr. M. Vignesh. So we will continue with the last lecture on transistors. So now we understand the basic operation of a transistor. Let's look at the different ways it can be connected in a circuit. A transistor has three terminals: emitter, base and collector. For practical applications, one of these terminals is made common to both the input and output circuits. Based on the common terminal, there are three transistor configurations. That is common base, common emitter, common collector. Each configuration has its own characteristics and is selected based on the application. Common base configuration. In the common base configuration, the base terminal is common to both the input and output circuits. The input is supplied between the base and emitter, while the output is taken between the collector and base. This configuration provides low input resistance and high output resistance. Although the current gain is less than 1, it offers good voltage gain. Because of its high frequency performance, the common base configuration is mainly used in communication circuits and radio frequency amplifiers. Next we will see common base input characteristics. This graph shows the input characteristics of the common base configuration. It represents the relationship between the emitter current and emitter base voltage for different collector base voltages. The graph is very similar to the forward characteristics of a diode because the emitter base junction is forward biased. As the input voltage increases, the emitter current also increases rapidly. Notice that the change in the collector base voltage has only a small effect on the emitter current. This slide shows the equation representation of input resistance voltage amplification factor, that is R suffix I, A suffix V. Next we will see the common base output characteristics. Now let's study the output characteristics of the common base configuration with respect to the graph shown. So this graph shows the relationship between the collector current and collector base voltage. There are three operating regions. The first is active region, where the transistor operates as an amplifier. The second is the cutoff region, where both the junctions are reverse biased and almost no current flows. The third is the saturation region, where both junctions are forward biased and the transistor behaves like a closed switch. Understanding these regions is essential because they determine how the transistor functions in different electronic circuits. So now we will discuss about each and every region in detail. In the active region, the emitter base junction is forward biased and the collector base junction is reverse biased. This is the normal operating region for amplifiers. In the cutoff region, both the junctions are reverse biased, the transistor is turned off and almost no current flows. In the saturation region, both junctions are forward biased, the transistor is fully on and behaves like a closed switch. These three regions form the basis of transistor operation in analog and digital electronics. So this slide shows the equation representation of output resistance, current amplification factor, that is R suffix O and A suffix I. Next we will discuss about the most widely used transistor configuration, that is common emitter configuration. Here the emitter terminal is common to both the input and output circuits. The input is applied between the base and emitter, while the output is taken between the collector and emitter. The common emitter configuration provides high current gain, good voltage gain and high power gain. Because of these advantages, it is widely used in amplifiers and switching circuits. Next we will see the input characteristics of common emitter configuration. This graph shows the input characteristics of the common emitter configuration. It represents the relationship between the base current and the base emitter voltage, just like a forward biased diode. The base current increases rapidly once the base emitter voltage reaches the required value. For silicon transistors, the voltage is approximately about 0.7 volts. The graph also shows that changing the collector emitter voltage has only a small effect on the base current. Now let's examine the output characteristics of the common emitter configuration. The graph shows the relationship between the collector current and the collector emitter voltage for different base currents. Again, we observe three regions. The active region is used for amplification, the cutoff region is used when transistor is off, the saturation region is used when transistor acts as a switch. This graph is very important because it helps engineers selecting the correct operating point for transistor circuits. So these are some points related to the regions of operation which we already discussed in the previous configuration. So now we will see some important parameters in common emitter configuration. These include input resistance, output resistance, current gain and voltage gain. These parameters help us understand how effectively the transistor amplifies the electrical signals. For example, a higher current gain means the small change in the base current produces a much larger change in the collector current. These characteristics are widely used in the design of amplifier circuits. The circuit shown here is the experimental setup used to obtain the common emitter characteristics. By varying the input voltage and measuring the corresponding base current and collector current, we can plot the input and output characteristics curves. These experiments are commonly performed in the electronics laboratories to verify transistor behavior and understand its practical operation. They also help students compare theoretical concepts with real circuit performance. So far we have discussed about two different transistor configurations. One is common base transistor configuration and common emitter transistor configuration. We have one more type of configuration also, that is common collector configuration. So that we will discuss in the next lecture. So the experimental setup for common emitter configuration alone shown in this lecture. So whereas the common base experimental setup also will be similar to what we are seeing in this slide. So the difference is the base terminal is common to both input and output. So the base is connected to the ground and will be applying the input between emitter and base, will be taking the output between collector and base. So that is the difference between the experimental setup for determining the CB characteristics and CE characteristics. I hope the lecture is clear to you. We'll discuss the remaining configurations and the upcoming lecture. Thank you for watching the lecture.